Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 8th grade topic, geometric translations. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even on homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 3 parts, so leave a like, smash the subscribe, and let's get started. Now, geometric translations are going to be transformations on your graph that are going to cause every point on that graph to move the same exact way. Once again, geometric translations are going to be transformations on your graph that cause every point on that graph to move the same exact way. What does that mean? So let's say we have a graph like this. A pretty simple graph, triangle here, with 3 points. So point A, point B, and point C. A geometric translation will cause point A, B, and C to move the same exact way. So let's say we had to go 1 to the left. That means A is going to move 1 space to the left. That means B is going to move 1 space to the left. And C is going to move 1 space to the left. Every point has to go the same exact distance and direction as the translation dictates. Not only do you go left and right, but you can also go up and down. So let's say you have to go 3 up. That means A is going to go up 3, B is going to go up 3, and C is going to go up 3. Once again, all points are going to move the same exact way. And you can even have pairs of translations. So let's say instead of just having left or right or up or down, you would have to go 2 to the right and 4 down. Let's say you have something like that. Well, that means that A is going to go 2 to the right and 4 down. And B also goes 2 to the right and 4 down. Now, you don't have to do it in the same exact order as long as you do it. So let's say C goes, well, I just said don't do it in the same exact order. I'm about to do the same exact order. Let's say C goes down 4 and then over 2. Now, when I say they move the same exact way, I mean they do pretty much the pair. Or if it's a single one, the single one. It doesn't mean that they have to go in the same exact order in this fashion. That's not what I'm talking about. As long as the end result, they all moved ideally the same exact way, that is what your translation is going to cover. Now, this may not make much sense since we don't have an XY plane here, but this is the idea of what your translation is going to cause your graph to do. But let's look at how this is going to act when you actually do have an XY plane behind you. Let's say we have an example like this, in which we have this graph, which is a triangle, ABC. We have 3 points here, and we have our XY plane, and we have our translation. It tells us to pretty much transform this in such a way where everything goes down 1 space. So we have to figure out what our transformation is going to look like after it's done. The first step you want to do is figure out what are your points. So I have A, B, and C here, but what are those points? So we have point A, point B, and point C. But what are they? So if we look at this graph, point A looks to be, what was the x-coordinate of point A? Well, 1, 2. So it's a 2 here. What's the y-coordinate? 1, 2, 3. So point A is going to be 2, 3. This is your first step. You have to figure out what the points are because you can't move them up or down or left or right without knowing what the point started at. Likewise, what is your B, your x-coordinate of your B? That's going to be 3, and your y-coordinate is going to be 1, 2, 3, 4, 5. Cool. C, what is your x-coordinate? 1, 2, 3, 4. And your y-coordinate is going to be 3. So this is our triangle here. Now our transformation, like I said, is going to work on every point, and it's telling us to go one down. Now, one down, when you're looking at the coordinate plane here, we're talking about the y-axis. So what this transformation is telling us to do is focus on the y-coordinate and move it down one for each one of these points. So we're going to pretty much start with each point, and it's this 2, 3 here, right? And then we're going to pretty much subtract 1, right? We're not going to subtract 1 from x, but we're going to subtract 1 from y. So a is going to subtract 1 from y, which results in a prime. I'm just a prime because it's transformation of a. And we don't subtract anything from that 2, so it stays 2. But we subtract 1 from this 3, so our final result is going to be an a 2, 2, or a prime 2, 2. So this goes to a prime of 2, 2. Let's do the same thing for our b. b is going to be 3, 5, and we're subtracting that 0, 1, and that is going to be what? When we subtract 0, 1 essentially from this 3, 5, we get b prime to be 3, 4, right? Because 5 minus 1 gives us 4, so our b prime, our transformed b point, is going to be 3, 4. Now let's do our c. So c has us looking at 4, 3. And we're going to subtract the 0, 1 again. Okay, let me explain this a little bit more in case you're confused about what we had just been doing. This right here, we're subtracting the 0, 1 here because this translation tells us to go 1 down. 1 down means we have to be on the y-axis, not the x-axis, so we're not doing anything to the x-coordinate. We're only manipulating the y-coordinate. And we have to go 1 down, not 1 up. That's why we subtract. So in case you were wondering why we're subtracting, it's because we're going down 1. So you could technically add and have a negative 1 here. It doesn't really matter. Once you understand the concept, this becomes a little bit more straightforward why we're subtracting here and not adding, and why we're in the y-coordinate instead of the x-coordinate. So our final result for this one is going to result in a c prime of 4, 2, right? 4, 2. So c prime is going to be 4, 2. So now that we have our a, b, and c primes, we can plot that. So the first step is figuring out what your points are. Your second step is figuring out what your transformed points are. And then your third step is going to be to plot those transformed points. So we have a prime at 2, 2. So we're going to be here, right? 2, 2. We have b prime at 3, 4. So 3, 1, 2, 3, 4 here. And we have c prime at 4, 2. So 1, 2, 3, 4, 2. And then you graph it. Now my graph isn't perfect. So you see it looks like it's moved a little bit more to the left, but that's not true. We quite literally just moved it down 1. And if you had perfect graphing paper, you would see that it has not moved any. But forgive me, this is kind of freehand and not everything is perfect. But this is the idea. We're just pretty much transforming this by shifting the whole thing down. And this is going to be our a prime, our c prime, and this is our b prime. Now translations, as you see, does not necessarily mean that you're going to be going to another quadrant. This is our first, second, third, and fourth quadrant. Some translations will keep you in the same quadrant as you see here, but others will transform you in such a way where you're moving from one to another quadrant. Let's look at one more example. Okay, so for this example, we have a trapezoid, and we have a translation that's a two-parter. We have to go to the left 7, and we have to go up 5. So we want to transform this in such a way where all our points are going to left 7 and up 5. Our first step, identify what the points currently are. So we have an A, we have a B, we have a C, and we have a D. And what are our points? What is A, B, C, and D? So our first step is identifying what this A is. What is this point A? So we're going over to the right 2, and we're going down. So we're negative y here. 1, 2, 3, 4, 5, 6. So it's going to be 2, negative 6. How about this point B? This is supposed to be 3 here, so it's supposed to be lined up. Forgive me, it's not exactly perfect, but we're going to be a 3. And we're going to go down 1, 2, 3, 4. So a negative 4. How about the C? This is 1, 2, 3, 4, 5. It's supposed to be 5. And we're also going down to this negative 4 here. And D is going to be 1, 2, 3, 4, 5, 6. 6. And we're going to go down 1, 2, 3, 4, 5, 6. So these are our points. We have A being 2, negative 6. B being 3, negative 4, C being 5, negative 4, and D being 6, negative 6. So now that we have our points A, B, C, and D, and we know exactly what their point coordinates are, let's figure out what the transformation, specifically this translation, is going to have us looking at. So we're going to start with A. We have to transform A. So A is going to start at 2, negative 6. And we need to go to the left 7 and up 5. Left 7 means we're going to be on the x-axis, right? Left and right means you're going on the x. Up and down means you're going on the y. So 7 is going to be our first portion here. And let me get some space because we want to be able to manipulate some negatives in case we need to. So this is going to be 7. And we have a 5 here. So I'm putting some space just in case we need some negatives. Because to the left means we're going more negative, right? We're going to be more negative. So we can technically do this. So we're going to add, right, a negative here. Now, why did I do that? Well, we need to go to the left 7, right? So that means 2 has to subtract 7. However, we need to go up 5. That means we need this 5 to pretty much make this a little less negative. So that's why this can't have a negative. So I could make that a negative, right? But that means I'm going to have to negate that as well. And that might not be as clear because we're supposed to be going up 5. And this is telling us, look like it's telling us at least to go down 5. So if you forget to distribute, that's going to be a problem. So in order to get around that, I'm going to add this, and I know that this tells me I need to go to the left 7, and I need to go up 5. So when you have more than one direction like you see here, it may make more sense to simply add outside and put your directions inside because it's a little bit clearer what you're trying to do, but as long as you get it correct, it doesn't really matter how you get that answer. So what is the result? 2 minus a 7 gives us a prime of negative 5. And negative 6 plus 5 gives us a negative 1. So we know that a prime is going to be negative 5, negative 1. B is going to start at 3, negative 4. And once again, we're going to be doing something like this. Plus your negative 7, 5, right? Left 7, up 5. This is going to result in a B prime of 3 minus 7 gives us a negative 4. Negative 4 plus 5 gives a positive 1. So this is going to be a B prime of negative 4, 1. C is starting at 5, negative 4. And if we're going to subtract that 7 from the x coordinate, our C prime is going to have a negative 2 now. And if we're going to add that 5, we're also going to have a 1 here. So C prime looks to be negative 2, 1. D is starting at 6, negative 6. So subtracting that 7 from your x coordinate gives us a negative 1. And adding that 5 gives us a negative 1. So D prime is going to be negative 1, negative 1. So now we have our transformed or translated points, A prime, B prime, C prime, and D prime. Let's plot them. Once we plot them, we've pretty much done this and we're done. So A prime is going to be negative 5, negative 1. So negative 5 means we're going to the left. So 1, 2, 3, 4, 5. And we're going down 1. So we're going to be right here. this b prime is going to be negative 4, 1, right? So we're going to go to the left, 1, 2, 3, 4, but we're going to go up 1 this time. So it's going to be right around here. The c prime means we're going to go negative 2, so 1, 2, and then go up 1 again. And our d prime means we're going to go negative 1 and then down 1. So when we connect these dots here, we see that our a prime, our b prime, c prime, and d prime actually moved and now is from the fourth quadrant into our second and third quadrant. So it doesn't really have to line up exactly into one, as long as whatever it's telling you to do up here, whatever translation it tells you to do, you apply that to every point on your graph. This trapezoid simply shifted up here. And once again, it may not look perfect here, but if you got graph paper and you were doing the same exact thing, it should look fairly identical. So I hope you follow into these examples. I hope you see that geometric translations don't have to be too difficult. As long as you're applying that same transformation to all your points, you are actually translating your graph. But if you did have any question about what you saw today, or even on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found it helpful, so can someone else. So leave a like, hit the notification bell, smash subscribe, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping it's helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.